Okay, so we're going to solve quadratics by graphing today. This is the third method we've learned for solving a quadratic. We've done factoring, we've done square roots, and now we're going to do graphing, which is by far the easiest way to solve a quadratic. That's why we do it at the end. Having a calculator is pretty important today. If you don't have one sitting at home where you can use it while we're going through these notes, at least write down the keystrokes or the buttons that we push to get from one place to the other, so that when you try to do this on your own, you won't have to be like, now what did she do? You need to at least write it down. The second thing is all of these notes are going to be posted on Edline. If you'll go grab a copy of them, it'll make it easier for you because there is some graphing involved. So let's start off. First question. Dolphin trainers at SeaWorld can use quadratic equations to plan the choreography for their shows. The quadratic function y equals negative 16x squared plus 20x can be used to model a dolphin's height above the water after x seconds. We're going to graph this using our calculator and then sketch the graph on our grid. So we're going to grab our calculator and we're going to go to y equals and we're going to type in the equation that we were given, which is negative 16x squared plus 20x. And we can graph it on our calculator, but what we really want to do is go look at the table so we can have points to plot, which will make it easier for us to sketch. We're going to go to second graph and look at the table. And we're going to fill in this table that's on our notes. And we're going to start at negative. We're not even going to start at negative. If you will see these numbers down here go by 0.25, goes 0.25, 0.5, 0.75, and 1. We're going to go change our window on our calculator so that this will count by 1/4. So we're going to go to second window. We want our table to start at 0 because our graph is only the positive numbers. And we want our delta table, or the change in our table, to be by 0.25 so that it shows us every 1/4 of a step. Now when we go to second table, it shows us all of those numbers. Well, so at 0, I have 0. So 0 is 0. Then at 0.25, it's 4. 0.5, it's 6. 0.5, it's also 6. And at 1, it is 4. So at 0.25, I have 4. At 0.5 it is 6, 0.75 it is also 6, and then at 1 it's back to 4, and then 1.25 would be the next one, just to go ahead and finish off our table. We're back to 0. So this is what our table is going to look like, and I'm going to plot these points on here to sketch my graph. So I have 0, 0. At 0.25 I'm at 4. At 0.5 it's at 6. 0.75 is also at 6, 1 is at 4, and 1.25 is back to 0. Somewhere in between here is where my vertex is going to be, and so it's going to go up and come back down, and my vertex is in here somewhere. We can go find it, but it does just say sketch it, so it doesn't have to be 100% accurate. But this is about what my parabola would look like. And what we're really concerned with on this graph, since we're solving by graphing, are where the x-intercepts are. So there are two of them. There's one here and one here. So we're going to answer some questions. About how long is the dolphin out of the water? Well, he's out of the water from here all the way up and then come back down to here. And if this is seconds and this is feet out of the water, he is out of the water for 1.25 seconds. Because at 1.25 seconds is when it comes back to 0, so the dolphin goes back into the water. So the roots of quadratic equations are called solutions of the equation, which you've heard this word several times. We've used solutions, we've used roots, we've used zeros, we've used x-intercepts. They all mean the same thing. You can find the roots of a quadratic equation by finding the x-intercept of the related quadratic function. So you can graph it, find out where it crosses the x-axis, and you have your solutions. So look at number 3 here. Number 3 says, what are the zeros of the function graph below? It's asking you, what are the zeros? Where are the answers? Well, the zeros of this function, there's one here, because that's where it crosses the x-axis, and there's another one here where it crosses the x-axis. So there are 2. This one on the left is at x equals negative 1, 2, 3, so x is negative 3. And the other one, this one over here on the right, is at x equals 0. So the roots of that function that are graphed are the zeros are at negative 3 and 0. And that's how we solve it, using a graph. You look at the graph, find out where the x-intercepts are, and you're done. So let's do a couple more. So number 4, we're going to complete the table that includes the solutions to this quadratic equation, and then we're going to graph it. Remember, it wants to include the solutions. So it wants to include where y equals 0. So I need zeros to show up here. And they're going to, just based on these numbers, but we're going to go back to our calculator. And this time we're going to enter that equation, the x squared minus 6x. So you go back to y equals, and we're going to enter x squared minus 6x, because that is the function that was given to us right here. And we're going to go back to the table, but let's reset it, because remember for the last problem, I changed my window to go by 1/4, and so it didn't, I could see everything that was going to be on my graph. Let's go back and reset it. So go back to second window, and this time we want our delta table, or our table start, to go by 1. So we want it to go by 1, 2, 3, 4 instead of counting by fractions. So now when you go to the table, second graph, we can see the numbers. The first thing in our table was the -1, and at -1, y is 7. At 0, it's 0. At 1, it's -5. At 3, it's at -9. And at 6, it's back at 0. So to fill in my table, this is -9 and this is 0. And I got all of this just using my calculator. So I'm going to plot these on my graph. These 2 points here and here should be my solutions, because that's the point where y equals 0. So my graph should cross the x-axis at 0 and again at 6. So we'll plot our points. So I have -1, 7, and then I have 0, 0. And then I have 1, -5, and then I have 3, -9, and then I have 6, 0. So this would be what my quadratic equation would look like. I know I didn't plot points up here, but you can use symmetry to see that that's about what it should look like. And my solutions are here and here. So the zeros are at 0, 0, right there at the origin, and again at 6, 0, because that's the other x-intercept. It crosses the x-axis at both of those points. Now number 5 and number 6 here ask for the ordered pairs that represents the root of the function, and we're going to use our calculator to find those. They don't give us a graph to draw the picture, so we're going to actually have our calculator go find it. Just like our calculator can find the intersection of 2 lines and give us an answer to a system of equations, our calculator can also, I apologize for that, give us the solutions to a quadratic. And so this is where you really need to write down the steps, because if you don't have a calculator sitting in front of you, you're going to want these steps. It makes your life so easy. So here's our equation, 5x squared plus 29x plus 20. So we're going to go to our calculator. We're going to go to y equals. We're going to type in 5x squared plus 29x plus 20. I think that's the right equation. Yes. So there's our equation. Now, that's what we're going to put in y1. In y2, we're going to put y equals 0. That will draw a line on the x-axis for us, and I'm going to tell you why we're going to do that, because what we want to know is where does this graph cross the x-axis. And so if I can find out where it crosses the x-axis where y equals 0, I know what my 2 roots are. And this is there's another way to do what I'm getting ready to show you, but this is much simpler. So we're going to graph this, and we're probably not going to be able to see everything. Oh, we can, look. You don't have to be able to see the entire parabola. Where the vertex is not important. What is important is that you see the 2 points where the parabola crosses the x-axis. It crosses it here and here. And we're going to go find out what those 2 points are, doing just like we did when we solved the system of equations. So to do that, what I'm looking for is where it intersects this point right here. That's why I put in the other line. I also want this intersection point, so I'm going to have to do this twice. So I'm going to go to second, trace, and I still want to find an intersection. Just like before when we did systems of equations, I still want to find an intersection. I put in 2 equations for a reason, so we're going to go to number 5. And we're going to hit enter twice. We're going to go enter, enter. You do not hit enter a 3rd time. It's not like with equations, enter, 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 done. Now we actually have to make a guess. because we are going to have to tell our calculator whether we want it to look for the root on the left or the root on the right. Let's do the left one first. So I need to arrow over until my little cursor is as close as I can get it to that root. It doesn't have to be exact, but it needs to be close. Otherwise, your calculator is not going to know which one to look for. This is how you tell it. Look for the one on the left. Then hit enter, and it will tell you that that root is at -5, 0. So over here, the ordered pairs where it represents the roots, one of them is -5, 0. To get the other one, we're going to repeat that same process. We're going to go second, trace. We want to find the intersection, but this time we want the one on the right. So we're going to hit enter twice, 1, 2. And then our guess this time, we have to arrow over until our little cursor is close to the one on the right. And then hit enter again, so it will look for that one, and it's going to tells you right now it's at -0.8 and 0. So it's not even a whole number, it's a decimal. So it is at -0.8, 0. You could also write this as -4/5, 0. That would be fine if you wanted to write the fraction, but the decimal is totally acceptable. So those are the roots of that function. We could factor that. We could go find the factors of that and solve it and do all of that, but who wants to mess with that? Our calculator will do it. So let's try again. Number 6. We wanted, this time they worded it different. This one says roots. This one says x-intercepts. They mean the same thing. So I want to find the x-intercepts of the graph of this equation. Problem is, this, it does not say y equals, or it doesn't equal 0, and so I can't do anything with it yet. I have got to make this equal 0, just like I did when I was factoring. So in order to do that, I'm going to add 4x to both sides. And so now I have -x² plus 4x minus 5 equals 0. And I'm going to go back to my calculator. And I'm going to go to y equals and clear out that equation. I'm going to enter in the new one. So I have -x² plus 4x minus 5. And I'm still going to keep the equals 0 down here because that is the that is the x-axis, and that's where we want to see where the intersection happens. So again, we're going to graph it. And as long as oh, looky there. As long as I can see where the parabola crosses the x-axis, then I can find my roots. Problem is, it doesn't appear that this parabola crosses the x-axis. Let's go make sure our equation's okay. I have -x² plus 4x minus, that is the correct equation. So if I look at this parabola, it's upside down like it should be because it is a -x², but it never crosses the x-axis. And because it never crosses the x-axis, it doesn't have x-intercepts. So this just has no solution. You can say it has no x-intercepts. It doesn't have any. You cannot say that the x-intercepts are 0. If you tell me that the x-intercepts are 0, you're telling me that it crosses the x-axis at the origin, and that's not the case. So this is one of those problems that has no solution because it never crosses the x-axis.